Hello, and welcome to Advent of Code 2016. This is Will getting ready for our 21st problem of the year. Got about 20 seconds left here. Got my Clojure environment ready, and I was doing some problems from last year, so now I'm including JSON just in case we get some JSON data. Just getting ready for the problem. And here we go. Breaking into scrambling first passwords. Our own scrambled password. Okay, implement the scrambler. All right. Series of operations, starting with the password, the operations in succession. Okay. Okay, and then the question is, what's the result of scrambling? All right, so some kind of hash function here. Oh boy. Okay, swap. Okay, swap, rotate. Okay, so these are the operations, and then this is what I have to do. Okay, swaps the. Oh, I got it. So, oh, I see. So I have to implement like a. Okay, interesting. All right. Okay. All right. So let's see. Could I do this with? Could I do this with regular expressions? Yeah, probably that's fastest. All right. So I need a parsing function here. So all right. What have we got? So. So let's see. We'll do something like use cond. Yeah, that's all right, I guess. Well, let's see. Is each of these going to be? I wonder if there's a pattern here. Not one I think that I need to. It's swap, move, reverse, rotate. Yeah. Okay, so I think x with. All right, so let's do swap something with something else. In fact, so what I can do is starts with swap like this before I go into my regex match here. And then something like zip map, or I think we can just go with this for now. All right, so these are my two swaps. Then there are then there's a rotate. Yeah, this. So rotate something with something else. Okay, and then we can just return that. Then what else? There's rotate based on position of letter something. Okay. Can we get an example of this? Like here, this letter, like that. And then we'll just do this. And then we're going to also want to decorate this stuff. All right, what else have we got? Reverse positions. Y. So maybe like this. Okay. Pretty straightforward. And then move position X to position Y should be removed and then inserted. Okay. And then maybe I'm actually gonna switch this out here. I'm gonna make this implementation fit with the rest of these here. Get rid of this and okay. Swap position this thing with position this thing. Okay, and then another one for swap letter with letter. Letter with letter. Rotate something. Rotate something steps. Then rotate based on rotate. Rotate. I see. So it's left or right. Steps like this. Okay, then let's see. I want to also include the type. So this is going to be like swap position here. Then select rotate based on position of letter. Rotate. So yep. Okay, and then each of these. So we got. Let's see. So swap position, swap letter. Rotate steps, rotate letter, and reverse. So we'll just call this reverse, and then this final one, move position something to something else. Okay, and then we'll just call this move. All right. So can we say, is it the case? So let's just try, we just do this map parse to my clipboard lines here. Copy these contents to my clipboard. Nothing has nothing anywhere. Let's see. Okay, swap position. So what's the problem here? Move position something to position something. What would be the problem with this? It's because that. Yep. Okay, so what we're looking for here, we want to verify every line parses. Okay, remove the lines where they parse. And it says rotate left one step, rotate left one step. Oh, I see. So step optional like that. Okay. This, that. Okay, so everything gets parsed. And I can do so what are we calling this here? Scramble. Scramble is going to be defined as a function that takes a command, the string and the command, and is multi-method in the command like that, and def method scramble for s. Let's see. So the command is actually, so we're going to make it based on the first s like this. So in this case, let's see. So a move. Let's do a move first. The letter which is at the index should be removed from the string, then inserted. Okay, so we have our string, and then we're going to have this, and then we know that we're going to have from to here, and these are move position to, which is at index. Okay, so I think we want to say take this many. No, does that work? Let's see. How do you insert into? Must be some kind of string operation. Java string class. I hope they could do something like this. Insert. No. I'm just going to return a string. Start with substring. The thing is that it's going to be two different situations based on whether it comes before or after. All right. Well, so I could just say if from is let's see. So if from is less than 2, then we can let's see. Okay, def method for this on move. We're going to say. We want to. So if we're saying move position 2 to position 4, and then is that replacing it? It's inserted so that it ends up. I see. So in this case, we do want to take 1 less than from the string. Then it's just easier like this. Let's just say let the C be nth on S of the from, like this. Then take decrement from the string, then put. Oh, hang on. Put this one on pause. Maybe doing these other ones will make it easier to reason about. Okay, so swapping letters, rotate a certain number of steps. So rotating steps, that's something that's easier in Clojure. So all right, so we're going to define our scramble method for a rotate steps on some S, and then this is going to be dir and n here. Okay, so we know that we need to parse n, and then let's see. So so different behavior. We will need different behavior based on left, right. So all right. So how are we going to shift it to the right, or to the left, I guess? So we would want to make a cycle out of S here. So let's see. We would want to then drop this many from that cycle, and then take count of S. This. Okay. And then so scramble ABCD of a rotate steps left 1 equal 1. All right, are we on the right track here? PCDA. Yes, that's correct. Okay, and then otherwise the dir is going to be right, and then I think we need to say like subtract count of S like this, just change how much we drop. And then in this case, Okay, all right. So rotate steps is done. Let's see. How about rotate based on means that the whole string should be rotated to the right based on the index of the letter X as determined before this instruction does any rotations. Got it? Okay. Once the indexes rotate the string to the right one time plus a number of times equal to that index plus one additional time if the index was at least 4. Okay. Oh, also, I guess that this thing, let's just keep it a string so that we have access to our string methods. All right, so this next one we're calling rotate, what did we call it? Rotate letter. All right, so this is just going to take the character C here. So let's get index of, and then does this take index of, is there not a string index of, and it could probably take a character. Index of ABC character like this. No, does not want that. I would have to, I don't know, turn it into an int. Okay, that's fine. Okay, so index of like this. Okay, and then, or I'll say the rotate is equal to, so is it guaranteed to exist? It means that the whole string based on index as determined before it does anything, rotate the string. So this is going to be add, or no, here, let's let this be this. And then rot is going to be add to this 1, and then if greater than or equal, at least 4. So if index is at least 4 than 1, otherwise 0, like this. And then a left rotation, we know how to do. Sorry, it's a right rotation, right? Rotated to the right. Okay, and then instead of this read string n, just do our rot here. Okay, let's see. So, are they going to provide an example of that? Well, let's put our own in here. Rotate letter based on string A, like this. Oh, interesting. That it will be a string, so maybe we can pull it out like that. Too few arguments to if. Right. There. Okay, and that looks correct. And then let's see if it were B, then yeah, okay. Okay, so rotate letter looks good. All right, reverse positions, then the span of letters at indexes X through Y, including the letters X and Y, should be reversed in order. Okay, so let's define a scramble of reverse. All right, and this is going to be, it's a reverse of X and Y here, and then let's see. So so what can we do? I think, let's take a quick look. Reverse. So scanning quickly seems to indicate that X will always be less than Y. All right, so in that situation, I'm going to apply a string of take 1 less than X. Nope, that won't work. I guess, yeah, right. Okay, so take X from the string, or concat. We want to take X from the string, then we want to reverse concat drop X from the string. Actually, I think there's a split. I think there's split at. Split at. There is. Okay, so I think that we want to reverse a split at. N is going to be, string of x. Let's see, our n. So let's see. So take. So we basically need to take. Yeah, this was better. So drop x from this thing, then take the difference between y and x here, then reverse that, and then finally drop y. Okay, and then scramble if our reverse is from 1 to 2, and I don't know how to create a sequence from an anonymous function. Apply stir reverse. Apply stir to concat this, followed by that's fine. Oh, I think right here, drop from S. And then also up here, this needs to be like that. Okay. A, B, C, D. Okay, so that is not right. So that it's supposed to include these. So let's see. So in this case, we'd be taking 1, which is correct. Then we're dropping 1, also correct. Then we're taking the difference there, which is 1. It actually needs to be 2 because it's inclusive. Okay. And then the problem here is that we're not dropping enough. Okay, and then I think that's right. Do they provide an example? No. All right. So we have rotate steps, rotate letter, reverse, still holding on move. Then we have swap position and swap letter. Okay. Swap position. And then what is the difference? I see. So these are all going to be pretty similar here. And that means I gotta figure out how I'm going to do this. Let's see. I guess what I could do is I could let the chars be a vector of the string, and then character x, nth chars x, cy, nth chars y. And then I can go take the chars, assoc read string x, cy, read string y, x, and then to this whole thing, I need to apply stir. Okay, and then if we have a swap position 1 and 2, right? String can't be cast to a number. String can't be cast to a number, but I'm reading it. Right. Yes. Yep. This would have been better to put in the parser. I probably would have ultimately saved time. Okay, that looks good. That looks good too. Okay. All right. Then we're going to define how to swap, what I call swap letter. All right. And then I think the implementation is going to be, okay, swap letter should be swapped regardless of where they appear in the string. Okay, so same kind of functionality, except we're also going to have ix here, which is going to be in my function signature. I'll call these, yeah, I'll keep calling them x and y. Index of, so these are strings, so I can probably just do sx, I think. Because you can say index of ABC string C, correct? Yes, okay. All right, and then y is that. Okay, and then this becomes ix, this becomes iy, pretty ugly code reuse. But that's just because I'm using multi-methods here. Okay, so let's try swap letter A with D. Key must be an integer. Oh, right. This should be ix, iy. Looks good. And then finally our move, which is going to be a lot easier now. So what we have to do is let this be that. And then what do they say? Move position X to position Y. And then what we're going to say is we want to take the chars, associate. Okay, so it means the letter which is at index X. So so I think say, yeah, get the thing at read string X. You're going to need that. And then we will also get the thing at Y. And then what happens to inserted, oh, hang on, which is at, should be removed from the string. Then inserted. Okay, so I think that we can take a vector and use disj on it. So we can go like this to take it out. We don't need that. Guess we might kind of need it. And then insert into a vector. I wonder if 0, 1, 2, can you say conj 1, 1 like this? That doesn't work. Sos is going to not give quite the right behavior. Closure insert into vector, okay? At a particular index. Okay, this is recommending that we use split at. Okay, is that okay? Such that it ends up at that character in the string. So remove this thing from it. That seems right. Then they're saying for pretend after. Yeah. Okay, I guess that's fine. So let's take this thing, split at the index that you want it to show up in. So we can say something like let before after be something like this. Okay, then apply stir to before cx after. Concat. And then I think this needs to be like that. Okay. Don't need CY here. And I'm definitely going to want to watch this in action. So, and then what if I want to move 1 to 2? Persistent vector can't be cast to a persistent set. Is that because of this? Is it possible to disj? No, apparently not. All right. So I guess that yeah, this still isn't quite right. This is a situation where having, I guess we could just use a byte array. So we could say get bytes ABC like this. That's not quite right either. Let's see. Am I missing something? I guess. Well, let's take a look at the existing moves here. Move, position. Okay, so it is definitely possible to move back. Okay, so let's try it. Let the C be the nth in S of read string. Okay, so we need to pick up. And then, in last case, we're going to be concatening. Okay, I think I got it. So we're going to drop the lesser of X and Y. From S. Then this is requiring me to, so I kind of keep too many things in my head to get this. Maybe I should just assume that X is less. So if I can assume that we're moving it to later in the string, I'm gonna go like this, because we're taking it out. Then we need to let's see. Then we need to take everything between X and Y. So that would be like, so take this, then drop that, and take the difference between X and Y. Here. And then put in our missing character. Then like drop like drop everything so add this to this and 1. Yikes. Yikes. Yeah, this is ugly. But it might work in the specific case that I've lined out here. So let's see if that's true. So No, it's not true. But at least the length is right. So let's see. So this is saying, so let's see, this is going to take one, pull it out. I wonder if it might be better to, maybe it's better to do it in two steps here. So like something like, let before after be the split at of read string x and s like this, and then let's see. So the one that is at that index. So then we're going to have to let after be the rest after. Okay, and then our new string is going to be concat apply str to concat before and after. So this at least gets us the string without that. Then in our next step, we do, yeah, this is just a much better way to do it. So then we do drop read string y from ss. Let me say this another split at, except this time on ss, and then finally we return concat the see here c and after is this, and then cat b. Okay, I think we finally got it. And don't know how to create a sequence from a character. Fair enough. Okay, all right. Okay, so bringing it all together now. What we want to do is, all right, so I'm going to def once the commands to be map parse to clipboard lines like this. Okay, then we want to reduce scramble, starting with our input and going over the commands. Our input is this. Okay, array 4, great. Where in the world is this at? And that's going to be the wrong command to look at. Let's try this again. Okay. Protocols, nth in where? Form init, seek reduce. You know what I can do here is I can, as part of this function, so you can sort of watch it in action here. Or can we? I think Clojure makes it. Yeah, what's happening here is that it's not letting me redefine this multi-method here. So I think if I say def, no. What do I need to do to make this work? I think there's like ns unmap in this ns, and like I like that. Okay, so that looks better on this all. Okay, there's the index out of bounds exception, except it should have, I think, given me my oh, because I took it out. Okay. All right, getting there, getting there. Okay, this is interesting. So rotate letter, it's telling me, needs to, at the very least, apply a string. Okay, I think it's getting further than last time. Wrong number of args passed to something in rest. This is in rotate letter here. Okay, so it's saying that if you try to do a rotate letter, wrong number of args is 0, pass to something in here. So index of S, E, okay, that should be fine. So let me just try manually calling scramble on this here and this here. Turn this into a vector. That went through. What is this is saying line 152. Right. This actually succeeded. Okay, here's our output. All right. Right answer. Rank 165. Wow. Okay. Right. Let's see. But you can't actually modify the password file on the system. You need to unscramble one of the existing passwords by reversing the scrambling process. Oh no. Oh no. That's yikes. Oh no. How are we going to? Huh. Okay. Well, the good news is, I guess a rotate, rotate steps is easy enough to reverse. That's as easy as this. There, okay. Did rotate steps. How about rotate letter? So in this situation, we're rotating the whole thing. Oh, okay, all right. So a rotate left around a letter, I guess, is the opposite of a rotate, or it's a, so we can just take, instead of rotating it, rotating it to the right, we can rotate it to the left like this. Okay. All right. Unable to resolve symbol. Oh, yeah. What was that? Oh, rot. That's what we called it. Okay. Then, all right, reversing a, I think reverse might be its own. Yeah, reverse is its own reverse operation, because you're just taking the same. If it runs twice on something, then you're undoing your behavior. Sure. Reverse on 3, and then well, I'm just going to assume that it works rather than okay. Then swap position. This also is its own reverse, so that's fine. Then swap letter, it's also its own reverse. Then move, let's see, so moving X to Y. So I think, is that just the same as moving, is the opposite of that moving Y to X? I think it's worth a shot. So let's try doing that then. Okay, so it hasn't changed. So what is the unscrambled version of this password? All right. I'm gonna try it. Not the right answer. Okay. All right, need to, oh, right. Okay, so at the very least, we need to reverse the commands. Okay. And yeah, we're not going to be able to submit for another 30 seconds. So this is in here. Yeah, verify. Yep, I think. Well, here what we can do is we can try to scramble this with a move from 2 to 1. See if that gives us. It does look right. Recently. Not the right answer. Okay. Okay. Okay, you'll need to unscramble one of the existing passwords by reversing the scrambling process. Okay, what is the unscrambled version of this? Yeah. Okay. So so it would have been nice if we had like made like a mirror copy of the code and then like actually verify. So let me take this. So in the first case, let me take this PRN out here. Okay. Then switch this back to this. Then put this back in. Put the take back in. Remember to switch it back to rot here. Okay. And then we said reverse is going to be the same. Swap position, swap letter are going to be the same, and then move just like this here. Okay. Then, and this is going to be a huge amount of code duplicated. But let's define unscramble. Yeah, not running out of space in the editor. Unscramble, 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 like that, and finally like this. Okay. All right, and then we figured that that would be the case, and that this would be the case. This other take here. Wait a second. I'm just going to verify that this actually is different. Yep. Okay. Unscramble. Okay, good. Definition of unscramble is the same. Definition of swap position is the same. Swap letter and then unscramble on move is just to that. Okay, so I guess what we want to do is we want to use unscramble on the reverse of the commands gives this. Therefore, reduce scramble on this on the forwards of the commands, and it doesn't give the right answer. Okay. All right. We got a whole bunch of test cases here, so let's find out. Let's try taking the unscramble of this operation. All right, that looks good. Unscramble this operation. Not right. Okay. So what's going on here? I think so. Rotate letter. I think the problem is that it's going to the in one direction. We need to have it go in the other direction. So so yeah, where this one is is dropping rot here, I think we need to subtract from the count of S. All right, now let's try unscrambling. Nope. Okay, still wrong. All right, did we fix this anyway? No, we didn't even fix this. Okay, I thought that was doing a left shift, but I guess not. Okay. So I think, could it have to do with the fact? I'm not sure. All right, this should be easy enough to look at. And then when the rotate letter B comes around, we basically know that we're going to need to rotate the whole thing. Okay, so let's go back up to the unscramble here. Rotate letter. Let's see. So find the letter, and then this rot thing. This is just wrong. So all right. So how are we going to do this? We need to, I think, we need to figure out if the index would be at least 4. If where we're rotating it to is at least 4. Let's see. So take counts from drop. Okay, I think that's right. In terms of, okay, so what do we actually get out when we do the unscramble? Why is it wrong? It seems to be wrong because it's not doing anything. Why is it not doing anything? So I think so. It needs to when it finds out that it's rotate letter B. How is it supposed to know where it came from? It can't. You can't look at the string and then look at rotate letter B to know where it. Okay, so this is actually turning into. This is actually like a kind of like a search problem. Okay, how many rotate letters do we have here? Rotate letter or rotate based. Okay. Huh. All right. So there's a bunch of those. So our reduce is not going to be quite sufficient. I think what we need is like, I mean, unless we try to get there, like, I guess with random, like we just try to get lucky, just run like 100 or like 10,000 trials or something. Well, I guess that if we wanted to do that, then we would need to, in the first place, verify that the rest of our unscrambles unscramble. So move 1, 2 like this. Okay. All right. That's so. I think that is that all. Rotate steps. Rotate letter. Gonna assume reverse is okay. And then what we could do is we could define trial for some s, and then we could say let canned, and then if candidate is equal to our input, and then we could say something like take 1,000 of repeatedly trial, or I guess like this, and then in unscramble of rotate letter, we let the index be rand int of the count of s. Or actually, I guess we don't need index. So we just do this. It's just this raw here. There's that. All right, it's going to be pretty gnarly, but maybe we can get lucky. I wonder what the odds are of. It can't be that bad. Remove the nils from this first. Not looking so promising. Also, I'm surprised it's taking this long. It seems like it only took like I mean, it seemed like it took less than a second. And then if we don't do this, then we're gonna have to oh, hang on a sec. We might have just gotten lucky. Not the right answer. Oh, come on. Oh no. We need to be returning the candidate. All right. Well, it worked last time. So let's try it again, leveraging that random number generator to get us. Okay, let's try it. Actually, I think it's been less than a minute. Okay. Too recently, gotta wait 22 seconds. Okay. Seven seconds. And here we go. Not the right answer. I have to wait 5 minutes. That's interesting because my current password is this, and it's telling me that if I do that on commands, and the result is, well, I guess that what must have happened is that I screwed up. I must have just screwed up my. No, that's right. Okay, that's a little surprising, I guess. So, yeah, so jump back here. So it's saying, so this is the guess. We put this in here. All right. Puzzle input hasn't changed. If I run my program on this here, then I get the correct answer like this. You'll need to unscramble one of the existing passwords by reversing the scrambling process. What is the unscrambled version of the scrambled password that? Well, so I'm thinking, because so unscramble can't be the problem really can't be with unscramble in this situation, because I have my sort of my candidate here, and that candidate is verified to be okay with like it produces this, or does it produce this? I mean, I guess always check. FBG DCEAH. Huh. All right. So I guess that this points to some problem in Scramble that wasn't um, encountered in the original program. Yeah, I wonder if for example, that my program might be able to find more than one of these strings that happen to scramble to the target. Yeah, I guess that's a possibility. Huh. Is it a possibility? Because I think that each of these, I don't think that information is ever lost in any of these steps. So it would seem like maybe there's only one way to get there. Maybe not. Yeah. I don't know. I'm gonna wait for this to come back and try to inform the next direction of investigation. Am I understanding what it is that I have to do? What is the unscrambled version of the scrambled password? That. Huh. Huh. Yeah, I guess test cases is the next place to go with it. So, all right. So yeah, let's test it. Okay. There we go. Scramble. ACE. And still waiting for this to give us some output here. All right. So if it's, and then we'll just use our parse function. So and parse this output. Yeah, looks right. Okay. Oh, interesting. Swap letter D with letter B is giving swaps the positions of D and B. Oh, I see. This is got it. Yeah. So yeah, maybe better to thought for a second there that I found a bug. All right, then scramble this way. Yep. Okay, then how about this? Let's run down here. All right, then A, B, C, D, E. Yep. Rotate one left step. B, C, A, E. Rotate left one step. B, C, B, A, E. It should actually be this. Okay, well, that's a problem. Okay, good. So we found a problem. My guess is that I did not properly replace the definition of my definition of scramble. Glad I went back in here. The only thing I'm thinking is how could my old implementation have produced the right answer? But I guess that's what it was. So yeah, I think so. Should this be right or left? So if it's to the left, then this looks correct. And if it's to the right, then this also looks correct. Okay, I'm confused. Let's compare. You know what I could do is I could interleave these definitions. So yeah, let's find the other rotate steps here. So the scramble and unscramble look right. I must be maybe I'm misinterpreting what rotate step does. Nope, I just left this out. Okay. Okay, B, C, D, E, A. Yep. Huh, what is? I'm very surprised this is taking so long. I'm going to change this actually to a do seek for X in this here. Okay. All right. Next step. Down here. B, C, B, E, A, C. Okay, then this one. A, B, D, E, C. Yep. And this one. E, C, A, B, D. Yep. And this one. Aha. Aha. Okay. Because the index was at least 4, total of 6 right rotations. Okay. That's probably what it is. Okay, so it's saying it's a total of 6 right rotations, and then that means, okay, I think I got it? What is the problem here? Rotate right. Not like that. called rotate letter, and take the index as the index of the, so it's 4, rotates the string right once, plus the number of times equal to the index, plus an additional time. So this should be 6, I think. Does the, wonder if the issue comes from, so this should be, oh, I see the issue. Yeah, so this is working out. So this is not, yeah, this is going to be like a negative number, I think. So like drop -1 from 1, 2, 3, like this. Yep, that's it. So I think we just multiply this by like 10. That would probably fix it. Multiplying it by 2 would actually probably be sufficient. Decab. Okay. All right. So, yeah, it's finding more candidates than I'm comfortable with. But let's go through all this and then kick off our searcher again. Wow, yeah. Going through the test cases definitely proved to be valuable. Too bad that we hit it on the exact last test case, and it was something, I guess, that didn't come up in stage 1. Yeah, so not a whole lot of spare time to write a proper search algorithm, which I'm sure would have turned up our string already. But this is more exciting, I guess, because you never know when the proper input is going to get kicked out at you. Yeah, so I guess also maybe what we can do is just sort of like verify that none of these give the proper output here now that that's been fixed. If deb, yep, it's not correct. This, yeah, not correct. Yeah, I wonder if making this fix means that these matches are, oh, here's a match. Oh, oh no, that looks FB, GD, CEA. All right, here we go. Feeling lucky. Yeah, the right answer. All right, rank 189. A lot higher than I thought I'd be on this problem. So probably dropping a few places on the leaderboard here. Yeah, 72nd place. Been hovering in the high 60s, low 70s for a few days now. Let's talk about the problem a little bit. So this is implementing a hash function here, where the steps of the hash function are given as a sequence of kind of English-y steps to take, all in order. This turned out to be a ton of code. I don't think this is more code than I've ever written for an Advent code problem, and some of that is probably just not a great design, sort of ad hoc, like even starting up here with the parser. yeah, like if so, I do have Instaparse in this environment. It would have been available to me, but I thought that that the parsing would be the slow part, and so I just wanted to get get it done as soon as possible. And yeah, as far as the data structure goes, could have done worse, but basically we're taking this we're prepending the list of regex matches with the type that it is, and then I used closure multi methods to define the individual pieces of the of the hash function, the individual types of steps that we could take, and it wasn't great. This I feel like I kind of bumped up against like some limitations of closure compared to like a Python or a Perl or a language with sort of stronger string manipulation behavior built in. Even though it has the string manipulation of Java, a lot of my solutions were sort of based around treating a string like a sequence of characters, which is fine if you're writing like one of these, but if you have to write like 12, then like can you even really like look at this and tell what's happening, or this, so so yeah, ton of code ended up getting written, and it's all kind of pretty hacky. Thankfully there were test cases, so I was able to like try to verify the behavior. But yeah, so essentially my implementation is just, okay, I know what all of these individual steps are, and this is how I'm gonna implement them. Move took me a ton of time. The solution that because I think the big problem was that I was trying to do it all in one step, but it was a lot easier to do, easy. This function is just a mess, but it was a lot easier to do when I first got out my string without the character that was getting moved, and then sort of inserted it in. So that was fairly straightforward. And then that was enough to get the first part of the problem. And then the second part, where they asked us to unscramble. So that was, I thought, a really cool direction to take the problem into, because yeah, there's a lot of parts about it. It's can you figure out which of these functions needs to be inverted? How do you invert it? And then in the case of rotate letter, I'm pretty sure about this, that there is no way to just invert this. That it's from our perspective, it's essentially non-deterministic. So the proper approach, if you have enough of these, is that you need to search basically, and do like some kind of like a breadth first search, depth first search. I don't think that you can get a whole lot of information about how well you're doing just because the letters get so mixed up by the time you go through the whole algorithm. So you probably just have to explore all the different options. I didn't go that route when I implemented my unscramble. I just randomized. Where is it? Unscramble on rotate letter. Here we go. Yeah, so I just grabbed a random integer between 0 and 1 less than the count of the string, and then just had my REPL sort of crank. I did 100,000 trials. That turned out to be enough. I wonder, on average, how many trials would need to be done. So this string has length length 8, and this is, let's see, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that would be 8 to the 15. That's saying this seems to be saying that there are 3 times 10 to the 8, 10 to the 13 different ways that you can explore it. That's surprising, and I'd also be surprised that in 100,000 trials that's how I was actually able to get out the answer. Yeah, but maybe there's some kind of structure that I'm just not noticing right now. So yeah, so after a few false starts with unscramble, and even so, it turns out that there was a bug in my implementation of rotate based on position that just never came up in part 1. So that was especially confusing because it looked like that I had, I could run scramble on an input and get it looked like I was getting the right answer. It's just that the website wasn't accepting it. So yeah, that is what informed me that I probably had a bug somewhere, and I did, and I fixed it, and we got our right answer. Let's take a look at our advent calendar. All right. Okay. Kind of. Oh, I got a little. Just a little bit of, looks like brown right here on the side of this building. So maybe this is the maybe this is like the trunk of a Christmas tree or something that's gonna get shown up here. But all right, in the final stretches, it feels like Christmas is right around the corner. I'm very excited to be doing these last 4 problems, and I will be back at it tomorrow. Thanks for watching.